Hey everyone! In the last video, we talked about finding the equations of a line given either the y-intercept and the slope, or a point and the slope, or even just 2 points. And what we're going to be doing is finding equations of lines that are either parallel or perpendicular to a given line. So the best way to do this is by example. Alright, first up, we're going to find the equation of a line parallel to y equals 2x minus 3 that goes through the point negative 2, 1. I'm going to write the equation in slope-intercept form. All right, so let's remember what the rule is for parallel lines. Remember that parallel lines are the ones that never intersect. So they look like this. And most importantly, they have the same slope. So right off the bat, that already gives us a good amount of information. This tells us that m has to be 2. So we know the slope. We also know a point on the line. So we can go ahead and reference our point slope formula for the line. And then we're just going to put in the information that we have. We want the final answer to be in slope-intercept form, so let's do that. And there we have the equation y equals 2x minus 4. So this is a line that's parallel to the line y equals 2x minus 3, and it goes through the point negative 2, 1. Next up, we want to find an equation of the line parallel to 2x plus 3y equals 6. That goes through the point 0, 5. So this is going to require a little bit more heavy lifting because the equation that we're given right now is not in slope-intercept form. It's in standard form. So we're going to convert it to slope-intercept form, and then we can easily figure out what the slope is. Then we can get going on finding the parallel line. To start out, what I'm going to do is solve for y. And I end up with an equation of y equals 2 minus 2/3 x, or y equals negative 2/3 x plus 2. We're not done, though. This is just the original line. We want a line that's parallel to this one. So since we want a line that's parallel, we need a line that has a slope of negative 2/3. All right, now we're done. We have an equation with the same slope, so it's parallel, and it goes through the point 0, 5. And if you notice, the original point that we're given is the y-intercepts. So we could have directly gone to this y equals mx plus b form, but I think it's good to get some practice going between different forms of equations. All right, next I want to find the equation of a line perpendicular to y equals 2x minus 3, going through the point negative 2, 1. So perpendicular lines are the ones that intersect at a right angle. Two lines without a zero slope are going to be perpendicular to one another if and only if their slopes are opposite reciprocal. In the case that the slope is equal to 0 or undefined, a perpendicular line is the other one, basically. So if the original slope is 2, or in other words 2 over 1, then the opposite reciprocal would be negative 1 over 2. Alright, so now that we know the slope and we know a point here, we can go ahead and compute the equation. And there we have our line that's perpendicular to y equals 2x minus 3 and going through the point negative 2, 1. Here we want to find the equation of a line that's perpendicular to the line x equals negative 3 going through the point 5, negative 8. We can tell by the equation that the line is vertical, which means it has an undefined slope. So how do we compute the equation? Well, a line that is perpendicular to a vertical line is horizontal and vice versa. So we just need to find a horizontal line intersecting this vertical one and the point 5, negative 8. And we know that for horizontal lines, they look like y equals something. Since the y value never changes in a horizontal line, to make sure that it goes through the point 5, negative 8, all of the y values for the line have to be negative 8. And that's it. So actually, the vertical and horizontal line cases are much easier. Here we have a similar situation, except now we're starting with a line that is horizontal, and we want to find a line perpendicular to it. So vertical lines always look like x equals something. Since the x value in a vertical line never changes, it needs to be negative 2 to assure that our line goes through the point negative 2, 3. And that about wraps it up for equations of lines. In the next section, we're going to start talking about how to graph solutions of linear inequalities that have two variables.